This is a chat system developed by me and my partner Laura for the course ICS. So this chat includes three functions. One is secure messaging, the other is a GUI as well as a multiplayer snake game. So the secure message ensures the security of the transfer. The GUI makes sure the interface is user-friendly so that the user don't need to type in the command line. And the multiplayer snake game make the chat system more fun and interactive. And the players can compete with each other as well as chatting. Next, I'm going to show you the developing process for the game part and the GUI part by using a mind map. So this is our login interface. So basically you type in a name, for example, like Sissy, and then you type in random password without signing up. You click login, it says user does not exist. So you have to sign up. For example, you say Sissy and 1, 2, 3. And you sign up, it says register successful. And now if you type in the wrong password, you try to log in, it will say wrong password. Only with the correct password can you log into the chat system. So in order for 3 players to play the game, they have to be in the same chat group. Now I let Didi to send out the game invitation. And CC accept the invitation. One thing to notice is that instead of clicking the send button, we can simply press enter to send out the message. Now, the 3 game window will pop out simultaneously. And it's very hard to manipulate these on a different computer, on the same computer. So, yeah. So now I'm gonna let one of the player eaten by the other. Now we have one winner, which is the second user, because the second user actually eat the third user's snake. And the first user loses because he bumped into the wall, which is he reaches the boundary of this window. So I did 2 parts in total. The first is Squay, and the second is a multiplayer snake game. In this multiplayer snake game, I first let the client play with this game in the snake.py, and this the client will send information like which food is eaten and the snake coordinates, as well as if the snake bumped into the other to the server side. And then the server side will process these information in this handle message function, and the information including the other snake coordinates, as well as which food is eaten and which snake is eaten by the other snake. And these information will be processed and then sent to the other clients. For example, if one food is being eaten, the server will actually generate a new food position and will send this new food to the other clients. And if one of the client is the only player left in this game, the server will also send this win action to the player and to inform the player that he is the ultimate winner. And every information is sent to the client state machine. This information will be processed, and then the client will call multiple methods in the snake.py. For example, this self.game.clearSnake function will be called if one of the snake coordinates is sent to the other users. And then I'll talk about this accept and decline invitation module. So basically, if one client in the chatting process decided to start a game, it will type like a game into the chat box, and then it will send information to the server side. The server will say that if one client decided to start a game, I will send according information to the other clients to inform them. So basically, the server sent other clients the information suggesting that one of the user wanted to start the game. And then client B and client C get this information and print it out. Somebody invite you to play game on the screen. and then client B and client C has to respond accordingly. So their responses include decline or accept. These information will be sent to the server, and these responses will update the server-side dictionary, which is the self.game group. So this self.game group will trace every client's status, as well as what the client's name, as well as the client status, include accept or decline. And then the server side will decide, has everybody responded or not. If everybody has responded, the server side will send this start game information to the client that has accepted the invitation with the initial snake position, as well as the initial food position. And then I'll talk about the GUI part. So in this part, I did a login and register function. So here, as you can see on the interface, I have like this login and sign up button. So in this login button, I will send this username as well as the password to the server. And for the sign up function, if I click the sign up button, it will call the self.register user interface, which is, as you can see here, this is the interface for the register. And then this is the part on the client side, and all the information will be sent to the server. So like the server will detect which phase it is. If it's a register, the server will decide whether it is allowed or the username is actually existed. So it will send duplicate information back to the client. If it's a login phase, the server will first check if this user file exists. If the user file exists, it will then detect whether the password is correct or not. If the name file does not exist, which means the user has never registered before, it will tell the user that your name does not exist. Please register first. And all the information will be sent back to the client, which will be processed in this register function as well as this go ahead function. And so based on the information received, the client side will print out information accordingly.
We use RSA to secure message. It is an asymmetric cryptography that uses key pair to encrypt and decrypt messages. The steps include, first, generates users' own public key and private key pair when they log in. Then when peers want to be connected, they'll exchange their public keys with each other. While chatting, the message sent will be encrypted by peer's public key. Then the message received will be decrypted by user's own private key. After that, the chat history will be stored locally, and users will be able to search for the terms in previous chat history after they exit the chat group. To show it more clearly, I draw a mind map. These are the 4 states that users will experience. First, when they log in, they will generate a key pair. I import RSA from crypto to help me generate the key pair so that I do not need to write for the users. And then when 2 users want to be connected, they will send public keys to each other. I wrote a type in the protocol, which is called keys. When the server finds that the message type is key, they will directly send to the peers, and the peer will receive the public key and then store the public key in the dictionary whose key is peer's name and the value is peer's public key. Then we can go to chatting. When I want to send a message, I will first save the chat locally and then encrypt the message and send to each user in a for loop. I get the public key from the dictionary in the for loop. And in the protocol in state machine, I also make some changes. I add the to name, which is the person I want to send to, with the public key. and the type is called secure chat. So when the server receives the message and identify it is a secure chat, it will find the socket of the two user and send the encrypted message to him or her. And this is the code that I use for encryption. What I need to note here is that I also add a parameter which is called if private to judge whether it is a secure chat or not. So actually the code can be generalized to chatting, normal chatting and secure chatting. I also import a package called base64 to ensure that the message will not be modified and will be readable after encryption and decryption. When the user receives the message, they will decrypt the message using their own private key. This is also the code I use for encryption. It's actually the reverse form of encryption. And then they will save the chat locally after decryption. When the peer want to connect it to the people in the chat group, the people in the chat group will store the new peer's public key and also send their own public key to the new peer. So all the people in the chat group, including new peer, will update their dictionary that stores peer's public key. When I or my peer want to disconnect from the chat, the people leave will initialize their dictionary, and the people still in the chatting room will delete that peer's public key. Then if people want to quit the chat system, the chat history will be dumped and saved locally so that the users can still search for their previous chat history. Now we have 3 unconnected users in this chat system. Let one user securely chat with another one. We can see that CC and DD are connected, and DD can see CC's message. And when CC tap time, CC is the only one that can see this message. Let's see what happened to their dictionary. We find that CC and DD successfully exchange each other's public key and let another user join the chat group. You can see that CC and DD can know that FF joined, and they all can see FF's message. From the dictionary, we find that FF get CC and DD's public key when he joined, and CC and DD's dictionary updated FF's public key. That's why they can chat successfully and securely. What happened when one user type by, and we can see that DD and FF's dictionary delete CC's public key so that they do not need to send useless messages to unexisting users in the chat group. And when CC want to search in the chat history, say hi, we can find that CC can find the chat history he chat with his peers before. So in our secure messaging, we can chat with multiple players, and the time button will not affect their chatting, and they can still search the chat history. There are still some further improvements. First, we can combine normal chat and securely chat by adding 2 users. If the people in the normal chatting want to securely chat with another peer in the chat group, then the message will be invisible to other peers. Second, in the game, if one snake kills the other snake, then the snake will add length and add more points. Third, after the game, the ranking should be also shown on the screen, not only the winner, so that all the players will know their performance in the game.